let's do multiple transformations on one function. So far, we've taken a function and we've only dilated it, or we've only translated it, or we've only reflected it, okay? What does it look like when we do multiple transformations on the same function? And we're going to try and stick with 2 unless we're translating, because translating, we could do translation left or right and up or down simultaneously. And we're just going to do lots of examples. So let's take an exponential. Okay, we're going to do this with all different kinds of functions. So let's suppose we have f of x is equal to, let's do an exponential with a y-intercept even. So 3 is our y-intercept. So 3 times 7 to the 2x plus 1. We're going to take functions that are just all over the place here. Okay, so this is exponential. Remember, an exponential function has an x in the exponent. So this is an exponential. Okay, and we're going to do 2 things to this. So the first thing that we're going to do is we're going to vertically stretch by a factor of 4. And then we're going to translate what we did in 1 so we're going to take this new function and we're going to translate it -2, +3. Okay. You want to work with one transformation at a time. So let's go through this slowly. And this isn't that complicated because what you're doing is each time you're just taking this new function and you're doing one transformation on it. Okay, so work with one at a time and say, okay, I have 3 times 7 to the 2x plus 1, and we're vertically stretching by a factor of 4. Ignore the second step. Okay, so the first thing is work with one transformation at a time. The only exception to that rule is really translation, because you can do both translations simultaneously. So let's work with number 1 first. Okay, so it's vertical, so we're affecting the y. And I'm writing a lot more here than I might write for some of the future examples, just because it's the first one that we're doing. So it's vertical, so we affect the y. And when we say that we're affecting y, we're saying we affect the whole f of x. Okay? And it's a stretch. So a stretch, vertical stretch makes the graph narrower. So we're multiplying. Again, if you forget that, think back to the rubber band, okay? If we take a rubber band and we stretch it vertically, it's getting narrower. You can imagine also if you, this is not a good example. If you have, I want the giraffe to be one of our little animals here to help demonstrate, but they don't have good enough arms. Imagine if you put your arms above your head, okay? And somebody went to you and they took your fingertips and they stretched your arms up. The distance between your arms is getting narrower. And by contrast, if somebody came up above you and they pushed your arms down, the distance between your arms is going to get bigger. So that's another way of thinking narrower and wider for vertical. For horizontal, if somebody took your arms, one person on your left, one person on your right, and they started pulling on them, then you would be getting, then the distance would be getting wider. Whereas if two people came up and they started pushing your arms together on your left and on your right, then they're getting narrower. So that's just another way other than the rubber band to think about it in terms of you yourself, okay? So it's vertical, so we affect f of x. It's a stretch, which means it's a narrower. So we're multiplying. So what does this mean? This means that the new function notation is 4 times f of x, okay? The 4 is being multiplied. That's because it's a dilation, okay? And a stretch makes it narrower. And it's outside our parentheses here. It's in front of the f of x because it's vertical, okay? So what does this mean? This means that we're taking the whole function 3 times 7 to the 2x plus 1, and we're multiplying it by 4. And we could simplify this. Let's make this 3 look a little bit bigger. We could simplify this. I encourage you to simplify when you're doing more than one transformation. The reason why I would encourage it is because when you have a lot of parentheses, starts to get really confusing, okay? So this is a multiplication all the way across. So the parentheses actually don't mean anything. This is 12 times 7 to the 2x plus 1, okay? So I encourage you to simplify. I encourage you to get rid of as many parentheses as you can when you have multiple transformations. Because otherwise you just have lots and lots and lots of parentheses. And you'll see the difference for the next, when we do the translation. Okay, this is just going to make your life a lot easier. The 4 does not get distributed here. Remember, in order to distribute, what would happen is you would have multiplication on the outside and either addition or subtraction on the inside. This is multiplication all the way through. So that's why the 4 gets multiplied by the 3 and you get 12. It doesn't also get multiplied by 7. Okay, so this is the first one. Okay, so now we have to do the second one. So now we're going to translate 4f of x is equal to 12 times 7 to the 2x plus 1. So we're translating this function. And notice we have a new function notation as 4f of x. It's not just f of x. We're translating this. Okay, so start with your t. Negative 2 comma 3. What does this mean? The negative 2 says that we're going to the left. So remember, in the function, We add when we go to the left, but in the notation, it would be a negative sign. So we're going 2 to the left and 3 up. Okay. Well, 2 to the left says that we're adding to x. And the 3 up says we're adding to y. So notice how we're approaching this. Okay. The way that we approach this is we say, are we affecting the x or the y, right? So here we're saying, so we affect f of x. When we say adding to y, we're saying adding to f of x. Okay. And then we're saying, okay, well now what operation are we doing? So that was the second thing. We said, okay, we're multiplying. We did the same thing here. We said, okay, we're going 2 left. Left means that we're adding. What are we adding to? X. How do we know it's x? It's a horizontal transformation. Then we're going 3 up. What does that mean? We're adding to y. Okay. How do we know it's y? It's a vertical transformation. Up and down is vertical. Okay. So now don't worry about the 4f of x. Just concentrate on what this means. This is saying replace x with x plus 2. And this is saying add 3 to the end of the function. Okay, so let's do that. So the x gets replaced with x plus 2. And then we're just adding 3 to the end of the function. So the 4 is just something that's getting carried down, okay? So the x got replaced with x plus 2, and then we tacked on a plus 3. Now we're going to do the same thing on this side. On this side, our x gets replaced with x plus 2, and then we tack on a plus 3 to the end of the function. Okay, and here it might be helpful to have parentheses just because that plus 3 is kind of like all the way out on the end. You can also write this as 3 plus 12 times 7 to the 2x plus 2 plus 1. Now, if it doesn't say to simplify, you can leave it like this. If it said to simplify, then you would change this to 2x plus 5 because you would distribute the 2. You would get 2x plus 4 plus 1, which would give you 2x plus 5. Okay, you can see that if you didn't multiply the 4 times 3, then you would have extra parentheses in here. Already you have 2 sets. This would add in an extra set. Okay, and the 4, again, it just gets carried down. Don't get confused by this 4, okay? The reason why it's 4 f of x plus 2 plus 3 is because we're translating this function for f of x, not this one. We're translating the new function, okay? Let's take another example. So we're just going to do a bunch of these. Let's do, we'll call it g of x, and we'll do a polynomial function. Let's do 3x squared minus 2x plus 4. Okay. And we'll do 2 things. We'll horizontally stretch by a factor of 2. And we'll reflect in the y-axis. These lines just appear out of nowhere. Okay. Again, take it one transformation at a time. Okay. So the first thing that we're going to do is the horizontal stretch. Horizontal tells us we're affecting the x. This is a great point for you to pause the video and try it out on your own, okay? But if you want to walk through one more, that's okay too. So it's a horizontal stretch. So we affect the x. And a stretch. For horizontal is wider. So we divide. Okay. Notice we're going to these two questions that we had before. We're saying, are we affecting x or y? Because that tells us, is it going to be something that changes inside the parentheses, like this 3x? Or is it going to be something that changes outside the parentheses, affecting the whole f of x? Okay. In other words, are we putting our x in parentheses and replacing it? Or are we putting our whole function in parentheses and just tacking something onto it? That's the first question that we ask. Then we say, okay, now that we know that we're affecting x or y, what's the operation? If it's a dilation, meaning a vertical or horizontal stretch or shrink, then we know that we're multiplying or dividing. If it's a translation, we know that we're adding or subtracting. And if it's a reflection, we know that we're just putting in a negative sign. Okay, either it's going outside the function or it's going next to the x. Okay, so this is horizontal, so we affect x, and it gets wider, so we divide. And it's by a factor of 2. So this is telling us that it's g of x over 2. Okay, we know how to do this. Every x is being replaced by an x over 2. Okay. And this is enough. You don't have to simplify this. It could be very helpful to you, okay? Because then you are not changing as much. You don't have as many parentheses. In this case, you'll see in the next step that it doesn't really hurt or help you to simplify. So what you can do is you could start the next one, see if it makes a difference. Like here, it probably made a big enough difference to do it. And if it doesn't make a difference, then don't bother with the simplification. Here I'll do both, okay? So if we simplify, x over 2 squared is x squared over 4. So this becomes 3x squared over 4. Then this is just an x, and we have plus 4, okay? Or 3/4 x squared minus x plus 4, okay? So we could do this with both. Now the second one, it's a reflection in the y-axis. This is a horizontal change. So we affect x. And it's a reflection, so we just add a negative. So what does this mean? This means that our x gets replaced by negative x. Now we have to keep the x over 2 there because we're not transforming this function, we're transforming this one. So this, I'm going to write this a little bit more clearly because I feel like it's not. I hope that's better. So it becomes negative x over 2. Okay, so what does this mean? If we use the unsimplified version, we have negative x over 2 squared after the 3, and then minus 2 times negative x over 2 plus 4. Okay, or if we use the simplified version, we get 3 times negative x squared over 4 minus negative x plus 4. And if we really want to, we get 3x squared over 4 plus x plus 4. I have to rewrite it because you can't see the 4. This is a completely simplified version. Any of these answers would be okay. If it's not telling you to simplify, any of these answers would be okay. Okay, let's do another one. We're just going to do a bunch. Let's do an example. Let's do logarithmic. We'll keep it relatively simple. K of x is equal to log of 2x. And let's say that we translate -1, -3, and we'll reflect in the origin. Okay. So once again, we do one at a time. So we're going 1 left. So x becomes x plus 1. Right? When we go, this negative means that we're going to the left. But when we go to the left in a function, we add. So 1 left, so x becomes x plus 1. And we're going 3 down. So we subtract 3 from f of x. Or from k of x in this case. Okay, what does this mean? This means our new notation is k x plus 1 and then -3. Now these are our instructions. This is saying take every x and replace it with an x plus 1 and then just subtract 3 at the end. Our x becomes x plus 1 and then we're subtracting 3. Now we can simplify this. We don't have to, but we can. Okay, the simplifying makes it easier because we don't have negatives. Okay, we don't have non-negatives. We don't have parentheses. Okay. Okay, let's do our reflection in the origin. So a reflection in the origin affects both x and y. Okay, and we put in a negative sign because it's a reflection. Okay, so what does that mean? So here's the only part that you have to remember. You're affecting the y. You're affecting the whole function. So this whole function has to get put in parentheses. Okay, so notice that we're looking at notation and the actual function. The whole function has to get put in parentheses and a negative sign gets put in front of it. What's the whole function? This right here. And then the x gets replaced with a negative. So k of negative x plus 1 now, -3. So don't worry so much about, just take it, what's going on. I'm going to take the whole function, put it in parentheses. And this is why I said when you affect the whole function, sometimes it can be really helpful if you just always put it in parentheses, because then you'll never forget. Okay, and you'll never have to think about, well, does it get a parentheses or doesn't it? So we have this -3 here. If you only put a negative in front of the log and you don't put the whole thing in parentheses, then you're not reflecting this whole thing in the origin. You're just reflecting the part before you translated it. And this says translate first. Okay, so by habit, the whole function is going to have a negative in front of it. And then every time that you see an x, you're going to replace it with a -x. Okay, and you could see that this starts to get, even though we got rid of one of the parentheses, now we have extra parentheses. So it starts to get like really, really lots and lots of parentheses, okay? So be careful here, that's all. So do the parentheses like one at a time. That's why I say what we did is we put a negative and then we just put parentheses because we knew that the whole function was going to go in there. Okay, and this can be, the most that you can do with this is it becomes negative log of -2x plus 2. And then this -3 becomes a +3. Okay, because you're distributing this negative. You're distributing it to the log, and then you're distributing it to the minus. Okay, let's take another example. You can do like 10 transformations, okay? I'm not going to ask you to do more than 2 at a time. But if you can do 2, you should be able to do a third, okay? Let's take another example. Okay, let's do r of x is equal to, let's do an absolute value. We'll do -4x minus 3. Okay. And this one, we did translation and reflection, we did dilation and reflection, and we did dilation and translation. Let's do another dilation and translation. So this time, let's translate (4, 1), and then we'll vertically shrink by a factor of 2. Okay, you should try this on your own. Okay, this is the 4th one. You should try it on your own. So the first thing that we're going to do is translate. So this says that we're going 4 right. X becomes x minus 4. And we're going 1 up. So we add 1 to the whole function. So x becomes x plus 4. Sorry, x minus 4. Okay, and then we add 1 to the whole thing. So we have absolute value, -4, I see an x, my x's get replaced with x minus 4. Then we have a -3, and we add 1 to the whole thing. Again, I would encourage you to simplify to get rid of as many parentheses as possible. We wind up with -4x This is a plus 16 minus 3. So it becomes plus 13. So I'm taking out the algebra in the middle. Negative 4 times negative 4 is positive 16. We subtract 3. That gives us a positive 13. Okay? And then plus 1. Vertical shrink says we affect y and we divide. Okay, a shrink makes it narrow, makes our graph wider. Again, think of the rubber band and going top and bottom, and you're shrinking it. Okay, you're doing a vertical shrink. You do a vertical shrink, we put it together, it gets wider. So what does that mean? That means that we're taking the whole function, r of x minus 4 plus 1. And what are we doing to it? We're dividing. What are we dividing by? We're dividing by 2 because that's what we're shrinking by. So now that just means take this whole function, absolute value of negative 4x plus 13 plus 1, and divide the whole thing by 2. Okay, and that's it. That's all that we have to do there. Let's take another example. Let's do another polynomial. We'll do q of x is equal to 2x cubed minus x squared plus 5. Okay. And for this one, let's do a horizontal. Well, let's do a reflection and then let's reflect in the x-axis. And then we'll do a horizontal shrink by a factor of 3. Okay. This will be the last one that we do, and then we'll just take a quick look at some graphs. So a reflection in the x-axis tells us it's a horizontal change, a vertical change. So we affect y. That means essentially you're taking your whole function and you're putting it in parentheses. It's a reflection, so we add a negative. I'm saying put in a negative because I don't want you to think that we're doing plus minus. So this is saying that it's negative q of x. You take your whole function, put it in parentheses, and you put a negative sign in front of it. So notice what we did. It's a vertical change. So I put in a parentheses. That's where our function is going to go. And then whatever we have to do, whether it's adding, subtracting, multiplying, dividing, it's going to go outside of there. Okay? So we have a negative and then 2x cubed minus x squared plus 5. You can simplify it if you want. If you don't, it just means that you're going to have a lot more parentheses in there. Okay? If we simplify, this becomes negative 2x cubed plus x squared minus 5. Now, if it's a really hard simplification, like if you have to cube x minus 4, don't bother, okay? But this is simple enough. We're just distributing a minus. Okay. Horizontal shrink, we're affecting x. And a horizontal shrink says we multiply. So this negative just stays there. Just ignore it. It doesn't change anything, okay? You have to put it in, but just treat it like it's part of the whole function, because it is. Here, this is affecting x. So the only thing that's changing is what's inside the parentheses. We're shrinking by a factor of 3. This says multiply. So our x becomes 3x. What does this mean? The negative we already did, right? We don't have to worry about it again. All we have to do is say, okay, well, I'm horizontally shrinking by a factor of 3. That tells me replace every x with a 3x. So this becomes negative 2. Every x becomes 3x. And that's it. And you don't have to simplify unless somebody tells you to. Okay? And if we simplify, so this is your answer if you don't have to simplify. Okay, if you do have to simplify, again, I'm not going to go through the algebra really, right? The 3 gets distributed because you have to do the exponent first. So you get 27x cubed, but you're multiplied by negative 2. So it becomes negative 54 x cubed. Then 3x squared is 9x squared because you're distributing, minus 5. Okay. And once like this, yes, you may be asked to simplify, okay? But if we have been translating instead, okay, then you wouldn't be asked to. Okay, I changed my mind. Let's do one more. This only gets difficult if you're not working with one thing at a time and just thinking, what are we changing? Are we changing the x or are we changing the y? Okay. If you keep it to that simple micro level, then you're not going to have any trouble with this. It's when you try and combine everything and think about it all together that you start to get confused. When you think about, oh, wait, this has to be negative. Where is the negative coming from? The negative was already there. Okay. You're just keeping it there. That's all. So you're taking this and you're saying, what am I, the first one I'm not worried about. It's the second one, okay? So in the second one, you're saying, okay, well, this is my new function. What do I need to do with the new function? I need to replace x with 3x. So here, I just take the x and I replace it with 3x, okay? If we go back to some of the others, looking at just the second one, we reflect in the origin. So our x gets replaced with negative x, and we put parentheses around the whole thing, and we put a negative sign in front of it. So don't worry about this minus 3 or anything. Just say, I put parentheses around the whole thing and put a negative sign. I replace my x, I make it a negative x. And then you're doing the same thing over here. So you don't have to look at the left side in order to do the right. Same thing here, vertical shrink by a factor of 2. Well, we take this vertical shrink by a factor of 2, says you divide the whole function by 2. So this is the whole function, we divide it by 2. On this side, this is the whole function, we divide by 2. If we go to the one before that, this was the first one that we did with multiples. We have our function, okay? So the first one, I'm not worried about you're getting the first one because we have just g of x. It's the second one. Second one, we reflect in the y-axis. That tells us that our x is becoming negative. So every time that we see an x in this, we just replace it with a negative x. Every time that we see an x here, we replace it with a negative x. Okay. So let's take f of x. Well, we could go back to f of x. F of x is equal to, let's do a reciprocal function. 1 over x squared minus 5. Okay. And let's translate this. 3, negative 7. And then let's horizontally stretch by a factor of 6. Okay, so the first one should be your easiest one. The first one is telling you, okay, we're going 3 to the right and 7 down. So if we're going 3 right, x becomes x minus 3. 7 down just says subtract 7 from the function. Whatever the function is. Okay, so what does that mean? Our x gets replaced by x minus 3. And then we just tack on a minus 7. Our x gets replaced by x minus 3. And then we tack on a minus 7. Nothing spectacular about that. Okay, let's take the second one. A horizontal stretch by a factor of 6. We're affecting the x. Because it's a horizontal. It's a stretch. When we horizontally stretch, we're making it wider. Okay, we're taking this rubber band, we're stretching it horizontally. When we stretch it horizontally, it gets wider. So we divide. We're dividing by 6 because we were told we're dividing by a factor of 6. So this says replace every x with x over 6. So we're going to look here and we're going to say, okay, where do we see an x? Let's replace it with x over 6. Everything else just remains the same. And then we're going to come around to the other side. So notice here, it's not that helpful to square it, okay? So here, I wouldn't bother simplifying because to square it, you're just making your life harder. Don't simplify if it's going to make your life harder. Only simplify if it's going to make your life easier, okay? Unless it told you to. And in a case like this, it's really not going to do that. So we have 1 over, and this is saying replace x with x over 6. And this is your final answer. Okay? And that's it. So treat it one thing at a time. Say, okay, I'm affecting x, so this means whenever I see x, I'm dividing it by 6. So don't make it that you're looking at the whole thing all the time. If this had been a vertical stretch by a factor of 6, then this would have said, okay, multiply your whole function by 6. So you would have put this whole thing in parentheses, and then you just would have put a 6 in front of it. And you would have done the same thing here. You would have put the whole thing in parentheses and put a 6 in front of it if you were vertically stretching by 6. Okay, so just think about what each individual transformation is telling you to do, and that's going to tell you how to do this. Okay, that's going to tell you, okay, well, that's how I go about changing these functions. Okay, so the very last thing that I want to talk about is just the graphs. So the graphs are going to be much, much simpler in terms of, so let's just take an example. So if it tells you take x squared, so for example, it might say here's x squared, do x squared plus 1. So all you do is you just take each individual point. This tells you that it goes up by 1. So you just go up by 1. Okay. So if it tells you to, you're only going to have one transformation in those cases. So for graphing, determine what the transformation is. How do we determine this? You're going to look at the operation. Okay, in other words, plus or minus, multiplication or division, or just a negative sign. Okay, so you're going to look at the operation, and you're going to look at whether it changes x or y. And then you're just going to transform, you're going to perform that transformation on the points. Okay, so for example, we're not going to do a lot of these because these are much simpler. You're only going to get one transformation. So for example, if you're given you would be given an actual axis. I'm just doing a sketch. But if this is y equals x squared, or f of x equals x squared, then it might say draw or sketch the graph of x minus 1 squared. Okay, so this tells you, you should be able to do this yourself at this point. This becomes a x. You subtracted 1 from your x. This meant that you went to the right by 1. So this means this is your new vertex. This goes to the right by 1. This goes to the right by 1. Next point goes to the right by 1. So your graph should look like it went to the right by 1. Okay? Essentially, you're doing that with every point. So here, if this is this moved it up by 2, but if this was your original graph, you would just take this point, move it right 1. Take this point, move it right 1. Take this point, move it to the right by 1. Okay? If you have, for example, instead, let's do this one. Where this is f of x equals the absolute value of x plus 4, and it said draw the graph it'll either say negative f of x, let's say, or this should be a absolute value, or negative x plus 4. What does this tell you? You're putting a negative in front of the whole thing, okay? So here you're changing y. You're putting a negative in front of y. So this is a reflection in the x-axis. Okay, negative in front of y is a reflection in the x-axis. So you're just reflecting in the x-axis. Okay, that's all that you're doing. So it's going to be one transformation that you're being asked to do. And it might be a translation. It might mean move it 2 up and 3 to the right. And in a case like that, just take each point, move it 2 up and 3 to the right. Okay. And just to, this is not really anything extra. I just want to show you what the different graphs look like. So for example, we had absolute value of 3x plus 2. I just want to give you some idea as to what a graph like this looks like when we horizontally shrink it by a factor of 3, okay? So if we horizontally shrink this by a factor of 3, what that's telling us is that we multiply. Horizontal shrink means that it's getting narrower, so we multiply our x by 3x. And you can see, okay, that now it's growing much, much faster, okay? If we take, let's take a different graph. Let's take 3x cubed, okay? And let's vertically shrink this by a factor of 6. This is going to become 3x cubed, and it's a vertical shrink, okay? So because it's a vertical shrink, vertical shrink makes the graph wider, so we divide. We're dividing the whole function. Notice we put the whole 3x cubed in parentheses. And you can see it gets wider. It grows more slowly, right? Here at 1/2, we're at 1 over here. But at 1/2 on the red graph, we're nowhere close to 1. So it's growing much more slowly. So that's just what the dilation looks like. Okay, and that's it for transformations. So that's everything that you're going to get tested on for this unit. So it's 3 videos. There's the reflection, there's the translation, there's the dilation, and then in the dilation video here, we put everything together. Okay, that's it.